Hey, my name is Willie, and I'm back again. Tried charging that up to start that up, and I barely had enough juice to turn that over 10 seconds before that went dead. So I upgraded as usual. I got myself a lithium battery. Now I could have gotten a cheap lawnmower battery, but for this application it was better because this is like less than half the weight. It was also nice to have a little button here that told you if it was low, medium, or fully charged. So for this application it was better. And to run my tank heater for the propane, I put an extra cord in here with a fuse added in here. So that's going to go back in my B1 because that'll turn over that starter generator without a problem. That being said, let's move on to the fuel system. I'm going to put some information down in the description below as for finding these parts. Matter of fact, I'm going to take that air filter off and point that out quick. Hang on. Okay, now this is not a carburetor. A carburetor would vaporize a liquid to a gas. This is a venturi, so this is going to create a suction to pull the propane and mix it with the air. That's one of the reasons why you won't get as much power out of a propane system, because you're substituting the air with a gas. So you're displacing some of the air. Even then, the BTUs for propane isn't really all that far off from gasoline. Gasoline, I believe, was somewhere around 119,000 BTUs per gallon, which would be mixed at a 17-to-1 for a perfect mix, but usually they're running about a 14-to-1 or less. So you burn a little bit more fuel. I think the propane is running about a 16 or 17-to-1. You can probably go as high as a 19-to-1. I'm going to do some more research. I'll put the information in the description below this video. I'll put all the BTU information, the horsepower information, all kinds of any kind of information I can come up with that would aid in efficiencies and disefficiencies, buying parts or not buying parts. I mean, this is a venturi, as I was saying. This is designed to run on natural gas or propane. This is not a fuel shutoff valve. This is actually a valve to switch between the propane and natural gas, because the natural gas orifice is larger than the propane orifice. So this would be the natural gas adjustment screw here. Let me grab a flashlight. That'd be for adjusting the natural gas, and the screw down below that is the one for adjusting the propane. So you have to run 12 volts to this to run propane, and if you're on natural gas, you don't need to put 12 volts to this. And it's just a regular nipple that comes in here from the valve over there, which I'll get into. So there's really not a whole lot to that. Now I'm still going to have to come up with some sort of throttle for this. I'm not sure I'm going to do with that yet. I'm hoping maybe there's a go-kart specialist out there somewhere that's probably bypassed the governors on these and hooked up stuff to these. So we'll have to see what happens. I want to put a foot throttle on this engine, and I'll go over that in this video too. So it's going to be a longer video. So now we got our fuel system here. That's Venturi is specific to these Vanguard engines. You can probably use them anywhere from 14 all the way up to at least these 18s. It's a single barrel, but when you get to the higher horsepower engines, they started to have 2-barrel intakes. I believe that's something like $74 or something like that on Amazon. It could probably cost more from BRIGGS. The regulator, I think, was $85, this big piece of aluminum, and this was, I think, $19 for a 2-stage regulator. That's a vacuum-operated valve, and this is a pressure regulator. So we have our propane inlet here. I put a valve here. So if I want to hook up to the 1-pound cylinder, I can screw it right here. If I wanted to hook up a 20-pound cylinder, I can put an adapter here, which I'm going to put a filter here if I run the 20-pound cylinders. And I can run the hose to the back of the tractor. I'll come in, that'll be the inlet into here. Now this engine, being an 18 horse, is going to burn about 180,000 BTUs an hour of propane. So this is 190,000 BTU per hour regulator, so you need something that'll carry the flow. I tried a single stage and it didn't flow enough propane, so this is actually just big enough for the application here. This is 190,000, that's 180. And this also has a safety trip on it, so if it goes over 190,000 BTU demand, it'll click off, and in case there's a leak. And this is coming out, I believe, it's coming out at 11 to 14 inches of water, which is something like 8 ounces. The max inlet pressure to the vacuum regulator is 8 ounces. So like I said, I'll put that information in this description about the differences between inches of water and ounces of water, as well as the difference in tank pressures and why you would say need a heater. So probably an interesting read. Gonna hopefully have this done tomorrow. Today's Saturday. So that'll be the inlet, this is the outlet here, and this goes over to the vacuum operated valve. This is the fuel shutoff valve I'm going to be using. This will be limiting my RPM as well via the window switch, which I showed in the last video. And that goes down to the bottom of this vacuum operated valve. Now this is a Gerritson regulator. Forgot to put a video in my last description of another video, if that makes sense. I had another video up talking about this system. I forgot to put that video in the description of how these Gerritsons work. There's 3 little slots here that usually are specs for the valve itself. So this one will actually tell you the max inlet is 8 ounces of pressure. So you gotta make sure you have the right regulator with the right pressure. Some of those are adjustable, but you don't need to have an adjustable regulator for this system. You just plug and go, because they're more or less all about 8 ounces of standard pressure going to a house for the most part. And this would be the outlet right here. This would be the vacuum half of the valve assembly. So we're stepping down from high pressure to low pressure, and then having a regulator that's vacuum operated here, and that just goes to a tube to Venturi here. Not really complicated. So let me get everything hooked up here. Matter of fact, I forgot to talk about the wiring back here. I have my 12 volts come in here. So when the switch is in its neutral position, there'll be 12 volts going to the regulator, or I'm sorry, the valve back here. And then I have that grounded. I'm going to ground up here. Just don't have it hooked up right now, but it's going to go right there. So the valve always has a ground, and it gets 12 volts from here. When I add ground to the signal circuit, because I already have 12 volts going to the signal circuit for this relay, when you add ground, it flips it to a closed position, in which case there's no connection between the 12 volts positive to the valve, and then the valve will close, and then it shuts the fuel off and slows the engine down. So let me get everything hooked back up, and I'll show you the wonders of the window switch and what you can do with it. So it's gonna take me a while, but it won't take you that long, so hang on. Oh, my battery's going low. I gotta put it in the charger. Okay, hang on. Okay, I got my window switch set up. I was hoping I could set the on point to 0 RPMs. Unfortunately, until the engine starts up, this doesn't start working, so I can't have control to that 24/7. So I just had to set it up where once it reached a certain RPM, it would kick on instead of being on all the time, then turning off. If you want to I'll show you using this test light here some of the uses of this thing. Now, we have it set to turn on at 3,500 RPMs, which since we're going to be using it monitoring the waste spark, we're going to have it set up for 1 cylinder. So it's going to be measuring double RPM. So 3,500 after 3,500 is going to be something like 1,750 RPMs, which is just right around idle, high idle. And then the off point is going to be 4,500 RPMs, which is going to be 2,250. I'll show you what happens. You'll see the lights when it turns on. Let me get that. That's going to be when it turns on. It'll have a little bulb or a little light right here when it turns on. Will light up. The light here will light up when it turns off. And when it's in the neutral or below the on and off RPM, there won't be any lights. And it'll tell me the live RPM once it's running. And hopefully nothing's going to fall off the table. It's a moment of truth, we're going to be running it. Another thing we're going to be doing is looking at the temperature of this tank, which is 45 degrees right now. And I still got to fill that tank up, which I'm not going to get a video of refilling that. You can look up Flame King. That's all I can do. And I don't know why this thing doesn't want to focus today. Being stubborn. There we go. So I'm going to fill that tank up. I want to show you what happens when you run it off of a small tank. This tank has about 1/3 full. So about a worst case scenario, that thing's going to freeze pretty darn quickly. And it's going to be freezing down below this line. There's not a whole lot in there. So here we go. Kind of neat, isn't it? Now another thing, they have the opposite of that too. If you wanted to hook it up where it was normally closed open instead of normally open, because I'm hooked up to the normally open right now, it'll work the opposite direction. The light will be on all the time, and I can swap that around quick. I won't change any of the settings. Let me swap out those two wires just so you can see how it works. Now, just in the short time this thing's been running, we were at 45, it's already cooling down quite a bit. Let me turn this idle up. It's already starving for propane. Probably because there's not a lot in there. Oh yeah, it's already at 17. That's the problem. Because it won't run for very long and it starts freezing up. Doesn't boil off fast enough. You can see the frost coming off of it. It's freezing up, Scotty! See, once it gets below minus 44 degrees Fahrenheit, it quits boiling off. So that's the problem. Now it's the bottom of the tank, I'm sure, yeah, it's minus 17. It's just hard to get at the bottom of it, but yeah, it's minus 14. It's just that cold. The top of it's not going to be that cold because the propane isn't up here. The propane's boiling off down at the bottom, which is why I want to use a half-empty tank, so you can see how quick it gets cold. So that's my dilemma. So I'm already getting over at 14 minutes here, so this will be an overview of the window switch and fuel system. next I'm going to put the heater on here and show the full-fledged official run of it. So, not sure if I'm going to put this up today, which is Saturday, or tomorrow, which is Sunday. But if you enjoyed the video, make sure you give me a thumbs up, and have a good day. Bye.